Hi guys, it's Mr. Mustafa here. In today's video we are going to learn about packaging problems. Now very often we get the problem of packing small boxes into larger boxes, right? So we want to know how should we pack them so as to maximize the space and try to minimize the wastage in the box. So we want to try to compact these small boxes into the larger boxes as far as possible. So I have some very good questions here, approximately 5 questions. So from past papers. So let's see. There's question 1, question 2 was something on the cylinder, and question 3 a box problem as well. Question 4, a pretty simple problem, and question 5 we have a container with, I think they're packing TVs in there. Alright, so let us get straight into question 1, and we want to answer these types of questions. Right. So question 1, the small boxes must be packed in the big box, right? So we need to pack these small ones into the big ones. Verify which of the following packaging options will be cost effective. Option 1, the length of the small box along the length of the large box container. So we want to look at option 1. We want to pack length by length. The length of here should be matching with the length here, and the width of the small box along the box of the container, so the width with the length of the large one. Now it's good to write down these things. So height 1 for the larger box, then what's height 1 for the larger box? 24 centimeters, right? And height 2 for the smaller box is basically 6 centimeters. Then the width of the larger one is 40, and width of the smaller one is 4. So we don't need to put the centimeters there, it's the same unit of measurement. And then the length of the larger one is 56, and the length of the smaller one is basically 7, right? So option 1, you need to match the height with the height, the width with the width, and the length with the length. So let's look at option 1. So we can look at lengthwise. So lengthwise what we can say is 56 divided by 7, we should get 8, right? So if you're packing these small boxes along the length of the larger box, you should be able to pack 7 of them in the front row, right? Now remember, we also need to go this way, and then how many we can pack in different levels, like different stacks. So first we know in the front is just 8. We can pack 8 boxes here in the larger one. Then that's lengthwise. So we just took the length and divide by the length. Then the next one is, let's look at widthwise. Right, widthwise, we take the width of the larger one, which is 40, and we're dividing it by 4. 40 divided by 4, so we should get 10. Right. So in other words, I know I'm packing lengthwise. I've got 8 here, and if I go across, I can pack another 10 there. So at the bottom is 8 times 10. I'm packing 80 boxes of these small ones right at the bottom. Now I need to know height-wise. How many? Height-wise, how many can I pack? So 24 divided by 6. 24 divided by 6, we get an exact answer, which is 4. Therefore, total number of boxes that I can pack into the large one, total number of boxes to be filled in the larger one, total number of small boxes in large one, right, is equal to 8 times 4 times, or you can just go in order, 8 times 10 times 4, 8 times 10 times 4, and see what answer we get. 8 times 10 times 4, which is, you can use a calculator, right? So that's 8 times 4 is 32, times 10 is 320. Just to show you, so bring the calculator here in the side. So 8 times 10 times 4, right, 320. Let's double check all these calculations as well. 56 over 7, 56 divided by 7 is 8. You know 40 divided by 4 already, that is simple, and then 24 divided by 6, you should know that, that's 4, right? So 320 of the small boxes will be filled in the larger one, and you can see we're not getting any decimal commas, so basically this option 1 is kind of like already compact, there's no spaces in this, so basically the spaces are maximized, so it is full, you can't find any space in there. But let's look at option 2. They said verify which of the following packaging options will be cost effective, right? Cost effective, in other words, we want to maximize the space. Now option 2, the width of the small box along the box of the container. So let's look at option 2. I'm going to copy all this down so we don't have to keep on going back and forth, right? So let us cut this out and paste it here, because I'm trying to find option 2 now. So let's look at option 2. So we want to look at lengthwise. Now in lengthwise, what we're going to do is we're going to take the length, right, and we're going to divide it by the width. So we're packing it in, taking this width and placing it in the front of the length, right? So there's your front face. This is your front face for option 2. Whereas in option 1, we just took the box as it is and we placed it here. Now lengthwise, we're going to take 56 and remember these are all your small boxes, right, and these are your large box. So if you take 56 and if you divide it by 4, see what we get. Taking the length and we're dividing it by, open up my calculator, take 56 and we're going to divide it by 4, we are getting 14, right? So we have done these two. Let us tick 56 and we divide it by 4. Now we're going to take the width, we're going to do widthwise. Widthwise, we're going to take 40 and we're going to divide it by the length. So 40 divided by 7. So if I take 40 divided by 7, if I take 40 and if I divide it by 7, I'm getting, let us write down 5,71, which is approximately 5, because now you're going to have empty space, so you're kind of not maximizing your space in your, right? Then the last one is height wise. Height wise, what we can do is we take 24 and we divide it by 6. So basically we're not changing the height of the box. So 24 divided by 6 is just 4, right? Therefore, what do we have? Total number of small boxes to be, yeah, total number of small boxes that can fit into the larger one, into the larger box, is equal to 14 times 5 times 4. And if we work out 14 times 5 times 4, should get, see, 14 times 5 times 4, we are getting 280 boxes. And you can clearly see this is not compact, right? So in other words, we have empty spaces. The space is not maximized in option 2. So verify which of the following packaging options will be cost effective. So therefore option 1 will be cost effective. So let's write that down. Option 1 will be cost effective. Therefore option 1 will be cost effective, right? Because we can see you can fill more boxes, right? So if you fill more boxes and ship them, is better for the company, right? The saving cost. Whereas if you use option 2, is bad for the company, because now the balance of the boxes are just being left behind. So that's what we learn in packaging problems, like how to pack these boxes so as to maximize the space. In other words, we want to, yeah, let's look at example 2 now, guys. We want to determine how many tins, or yeah, how many cans or tins can fit inside this, right? How many of these cylinders or these tins can fit inside this box? So we got height in millimeters, and then we got the width in centimeters, and we got the length of this box in centimeters. So as it is, let us write down the height 1, then I want to write down width 1, then I want to write down length 1. So I know what I'm doing here. Let's see, length 1, and then height 2. Yeah, well, you're not going to get a width here, so yeah, you will get a width if you go across from here to there. All right, let's see. Let us write down height 1. Yes, height 1 and height 2 matters. What's height 1? So we got 180 millimeters, and if we divided it by 10, then we are going to get centimeters. Right, so we got 18 centimeters here for the height. The length is 85, so we can write down 85 here. The width is 43, right, perfect. The height for the cylinder or tin is 8,57, right? So we want to look at height wise. Remember, these cylinders, these tins, we want to pack it here, right, like this. So we want to see how many levels we can pack. So height wise you can say 18 divided by 8,57. So on the calculator we can say 18 divided by 8.57, and to look at 18 divided by, so we're getting 2,1, so approximately 2. So you can get 2 layers here, right? So let's erase this. So we're kind of packing 1 tin there and 1 tin there with little space because of this one here. obviously it's not going to fit exact. You are going to have a little space in there, but this is still good enough, like 2,1. If it was 2.9, then you will be wasting much space, but 2.1 is still good enough. Let's look at the width now. So I want to know from here to there how many I can pack, right? So what's important over here is the radius, right? So radius, not the radius, sorry, the diameter. The radius is 3.5, right? And so the diameter now becomes 7 centimeters. So we're not going to call it width one. We're going to take the length and divide it by the diameter. So diameter, which is 7. Yes, you don't have width and stuff over here, so you just need to divide by the diameter. So in a cylinder, we just got a diameter which is 7 centimeters. So we want to look at width-wise, length-wise. So we want to look at length-wise, how many of these cylinders we can fit along this length line, right? So this length here is 85, and if we divide it by 7, we should get, let's put the 2 higher up. So remember, 2 layers, 85 divided by 7, so you're going to take 85 over 7, we get an answer of 12,14. 12,14. So approximately 12 over here. Then what we have is width-wise. So we're going to take this width, right? And obviously we are packing the same cylinders here. So let us just look at this. So how many of these we can pack along this line? So remember, lengthwise we can pack 12 tons, right? 12 over here. Across, how many can we pack? We don't know, so we need to check width-wise. So width-wise, 43 divided by 7, which is equal to 43 over 7, and we have 6,14. So approximately 6, right? So we have 12 lengthwise, and widthwise we have 6, and 2 layers. So we just multiply everything out. Therefore, number of tons to be packed, right, is equal to 2 times 12 times 6, and we should get the answer, which is equal to 2 times 12 times 6, should get 144 tons to be packed. Let us look at question number 3. Nice question. Question number 3 is something like question number 1. Calculate the number of small boxes that can be packed in the larger box if it is packed along the container box if the length of the small width of the container of the box. So basically we want to pack the length with the width. So the width part should be showing the front face here. Yeah. So let us look at both. Let us look at this option, and I'll show you why the second option is not appropriate, where you won't be able to maximize the space. Basically what we did in question 1. So length 1 is equal to 54,8, width 1 is equal to 42,1, and height 1 is equal to 33,5. all centimeters. Watch out, there is a millimeter here, so we need to divide the second width, which is 8,7. The second length is 10,2 and the height is 6,5. So basically the height is being packed with the height, the length and the width. This is basically the small box, you need to pack the length with the width. So length and width, these two. So what's lengthwise? Lengthwise will be equal to 54.8 divided by 8,7. So if you take 54.8 and divide by 8,7, 54.8 divided by 8.7 should get an answer of 6,29, 6,3, which is approximately equal to 6. So I'm taking, this is the front face, so you kind of packing it there with this front face being here. The distance from there to there is the width, which is 8,7. So how many 8,7s can you pack along this length here? 6 of them. Then the next one we're looking at, remember the height is just height divided by height, we're not changing the height. So let us write height wise. Height wise we're getting 33,5 divided by 6,5, which is equal to 33.5 over 6.5, which is equal to 5,15, which is approximately equal to 5. So you got 5 layers of these boxes, right, to be packed along the height. Now we only left it, so we are done with these two, we're done with these two, now we're left with these two. So take the width wise. Width wise 42,1, and we're going to divide it by 10,2. Should get 42.1 divided by 10.2, and our answer here is 4,13, which is approximately equal to 4. Therefore, total number of small boxes to be packed is equal to 6 times 5 times 4. 6 times 5 times 4, which is equal to 6 times 5 times 4, which is again 6 times 5 times 4, which is equal to 120 boxes. So you can pack 120 boxes. What if you went and took the length and divided by the length and the width divided by the width and the height divided by height? You will definitely get a different answer. So let us try that out. We will get an incorrect answer. So what if I do that rather? If you do that, then it might not be an optimal option. It might not be maximizing the space. So let us have a look at that. Let me just insert some space here. Alright, so what if I went and did height divided by height? So I'm looking at height wise. If I take the height and divide by height, well, I've already done that calculation, which is 33.5 divided by 6,5. We got an answer of 5. Sorry, it wasn't 5, it was 5,15, then 5. And then we said it was 5. Then, if I take the length and divide by the length, if I take 54,8 and divide by 10,2, see what we get. 54.8 divided by 10.2, you're getting an answer of 5,37, so approximately equal to 5. Then widthwise, if I take 42,1 and if I divide by 8,7, see what answer I get. Should be equal to, not approximately equal to, widthwise I should get 42.1 divided by 8.7, and I am getting 4,84, so much of wastage of space, which is 4. Therefore, see what answer I get with this option. Number of boxes, I'm just getting 5 times 5 times 4. I'm getting 5 times 5 is 25, times 4 is 100 boxes, right? Which is clearly not an optimal solution, right? It is not an optimal solution. It is not maximizing the space, right? So this method will definitely be wrong, right? So we cannot do this, right? This here would definitely be wrong. We have to select this option here because we can pack more boxes, right? It is more compact than this one over here. I hope you understand, guys. Thank you.